I'm Alexis Mora and I'm going to explain how does a boost converter circuit works. We have in this circuit, we have a DC voltage in, an inductor, a diode, a capacitor and a resistance of load. And we have transistors that acts like a switch and it's controlled by a PWM control. So we can replace this transistor by a switch and this DC in by a real DC voltage source. When we have this switch opened, we are feeding the circuit with our DC voltage in. So when this is on, when this is opened, we have a current flowing around all the circuit. But we have three cases because this is an RLC circuit. We have the overdamped case, we have the critically damped case, and the underdamped case. So in the underdamped case, we have the current that is oscillating in the inductor. Is not really oscillating because we have this diode that doesn't allow negative currents. So the charge is going to be constant in this case, the current of the inductor. But returning to the other cases, we have the inductor charging current and the capacitor charging voltage. So when this is charged totally, we have that the inductor is a closed cable and we have opened capacitor. This is only what happens when we have the circuit charged. When we close this switch, the inductor starts to charge linear in a linear way. So we have the equation of the inductor charge, and it's linear because of the fundamental relationship between the voltage in the inductor and the current in the inductor. So we have this equation. So as we have the voltage of the inductor that is constant, because it's a voltage source, this integral is going to give a linear equation. So that's why we have a linear charging in this place. And then this circuit is going to open here. The diode is not going to receive any current, so the capacitor is going to discharge in the resistor, in the natural response of the capacitor. When we open again this switch, we have again another charge, but as this inductor is charged because of the source, we have a lot of current going right here. So it's going to increase the current that is going to the capacitor, increasing to the voltage that is going to fall in the resistance. So this is why this is a boost converter, because of the current that is going to be added to the capacitor and is going to increase the voltage in the resistance. But this resistance is going to have a voltage that is going to decrease because of the stabilization of the circuit. The circuit is going to stabilize again when the capacitor reaches the voltage that the DC source gives. So this is it. This is how the circuit works. Thanks.
Good night, my name is Arnold Pinto. I am going to talk about a circuit boost converter. A boost converter circuit is a DC to DC converter circuit that obtains a higher continuous voltage at its output than at its input. It is a type of switch and power supply has an advantage. First, performance with margins between 60% and 19% against 14% of linear power. Supply side it does not have resistive elements in the diagram. It has semiconductor that act as switches, which when crossing the current do no loss made in those elements. Second, reduce side for high output voltage increment. Third, unlike linear search, it allows to handle variable loads without regulation of the output voltage close to the nominal voltage. Second question about the application of the boost converter for reduce signs. For example, for hybrid vehicles, for increased voltage and satisfy a lighting network in a photovoltaic solar energy application where the input voltage of the solar panel varies with the weather condition. This converter can always decrease the voltage of the photovoltaic panel. Power factor correction to improve grid power quality for general use with electronic energy loads that require reactive power. For example, motors is another important application of boost converter. Thanks.